Hello and welcome to the Superposition Guys podcast. My name is Yuval, and my guest today is Esperanza Cunca Gomez, the head of strategy and outreach at Multiverse Computing. Esperanza and I discussed the company's focus on practical applications of quantum and quantum-inspired software to solve real-world problems, what types of inquiries they have been getting in recent months, the ethical implications of quantum, and much more. We hope you enjoyed this episode. Hello, Esperanza. Thank you for joining me today.
Thank you, Yuval, for having me.
So who are you and what do you do?
Well, I currently serve as head of strategy and outreach in Multiverse Computing. Multiverse is one of the largest quantum software companies in Europe. We are more than 80 people now from lots of nationalities, more than 30, I believe. And my distinguished colleagues, most of them hold PhDs. And we focus on the practical applications, and in my case, also the implications of quantum and quantum-inspired software. We work addressing real problems with clients that usually belong to, big corporations in general, but we are also very keen to engage to companies from other sectors and other sizes.
When companies approach you, how do they think about the problem? Do they think about, we have to try quantum because we want to see if it's good? Or do they say we have a business problem and maybe quantum is the solution?
Well, I think that in general, their vision is we have a business problem. We know that classically we are going to face some limitations, either in terms of cost, either in terms of time, or we might not even be sure if we can do this classically. And so they start considering other paradigms of computing, and quantum computing and quantum-inspired techniques are the ones that comes to their minds.
Some say that quantum-inspired is cheating, right? Because quantum-inspired actually runs on a classical computer. So why go into quantum if you can solve it classically? How do you see that?
Yeah, this is actually a fascinating debate that I have with a good friend of mine, and he says, well, quantum inspired is not really quantum, and this actually reminds me, I'm from Spain, from the south, from Seville, and there we have what we call the purist of flamenco, and these people believe that flamenco music should only follow very specific patterns and chords and so on and so forth. And you are right in the sense that, yeah, quantum inspired, at the end of the day, you execute that on classical machines. However, what I would say is let's not be constrained by names or by technologies. I mean, let's offer our clients and more generally society the best solution that we can provide. And I think as Feynman said, I think there is room for everyone at the bottom. I mean, there is room for pure quantum solutions. There is room for quantum inspired. There is room as well for pure classical solution. And my particularly obsession is to deliver my clients the best solution, whether it is, regardless of the technology. That is also why we always benchmark. And we benchmark the different technologies, we present the results, and then it's up to them to decide which road to go. What I would also advocate is to get prepared for any scenario and to bear in mind different time frames. So, for example, for some problems, quantum inspired might be something that a company could eventually integrate into their systems faster and in principle more easily, because at the end of the day it's a classical to classical integration, and probably the provider of that solution already works with the company. So that should be easier, at least in principle. But do not forget that pure quantum solutions are as well in the horizon, and one needs to get prepared for the integration of that as well.
If it's okay, let's talk about the last 6 months. And you've been delivering solutions. Could you tell me about some of the recent solutions that you've delivered? I'm curious what fields they were in, whether they're quantum or quantum inspired, basically anything that you could share.
Yeah, absolutely. Well, there's something that, it's sort of last 6 months, and it's also delivering solutions, but also in terms of demand, with our conversations with clients, there is a lot of interest in artificial vision. And artificial vision also is very, very related to artificial intelligence. So I think that some of our clients, or a significant number of them, are thinking, is there any way that we can enhance our current capabilities in this realm so we can perform better? So, and I think there is also some traction with in general, the artificial intelligence awareness that is now, people are thinking about that more broadly. Then also in the field of energy related to prediction. So weather forecasting is a great example of this. And those are the two main fields that come to my mind that recently we have delivered in this field, and we also see more and more interest in these two. And it makes sense because two very hot topics right now are artificial intelligence and sustainability and renewables energy.
When you say artificial vision, would that translate into a machine learning algorithm for image classification, or is it something else?
Yeah, it's basically machine learning for image classification, typically detecting anomalies wherever those anomalies are. So it can be anomalies in a certain material, anomalies in something that you are manufacturing, or in other fields. But yeah, in general, I would say is algorithms, machine learning algorithms for image classification and defect detection, whichever those defects are.
Just going back to a previous question, are these quantum algorithms or more on the quantum inspired side?
I would say both. We do both, and we benchmark those.
As I read some of your writing and look at some of your public appearances, I think you're also interested in the meaning of quantum. What does that mean to you?
Yeah, this is a great question, and it has also been very influenced by a program that I'm currently taking, which is called Tech and Society by the Telefónica Foundation and the Aspen Institute in Spain, and also some readings that I have been doing as part of that program. And I like a lot a sentence by two prominent futurists, which are called Ruby and Dan, if I'm pronouncing their surnames well. And they say, we need to move beyond applications to implications. So during our discussion so far, we have talked about applications, and we are basically answering the question of what do we do with this technology? So we talk about artificial visions, we talk about, for example, weather prediction, and we can think about many, many other applications. Now, for me, a fundamental question very related to that is, which are the implications of all of this, right? And so how does all of these contribute to our economies and societies? Do all of these contribute to the common good? And which are the unintended consequences? And on a broader, let's say, perspective, Jack Hidari and other people in the quantum sphere, but particularly comes to my mind the work of Jack Hidari when he wrote about the quantum divide for the World Economic Forum. So I think these are the fundamental questions that we as a community should work towards answer to those. And because also in the artificial intelligence, we have seen, well, a lot of things, and I'm hoping some of them good, some of them not so good, and I'm hoping that in quantum we are able to anticipate, answers to those questions.
Do you think quantum is unique in that regards? One could say that every technology has both good applications and bad applications, could be used for good, could be used by evil people. Is quantum any different, or is it just that the scale or the potential transformative effect is larger?
Well, on one side, I would say that quantum is not per se different, and many of the, to put it this way, many of the ethical dilemmas that we might find are pretty much the ones that we would find in any other technology, at least for the moment. Then I also like to say that there are still applications of quantum that we are not even able to foresee at this stage. But maybe what we can think about is to try to have these conversations at early as possible. And I believe these are conversations worth having, regardless of if they are specific to the technology, because maybe we can think of applications that we can only do with quantum, even if some of those applications we cannot even imagine now. And then, of course, another part will be cross to any technology. But for me, the crucial point is to have the conversations, and here I add a sense of urgency.
One of the things that we see today is an influx of national quantum programs where many countries in Europe and elsewhere are trying to set up local quantum ecosystem because they think about quantum as a strategic technology. How do you think about that in the context of the common global good versus sort of the national interest of having something that your neighbor nation does not?
Well, this is actually a question very tied to the quantum divide. And some questions around this is, well, are we creating more inequality than equality as a result of these quantum national programs, and what these funds are actually being used for? So yeah, I mean, those are the difficult questions. On the other hand, I absolutely understand that for countries, quantum is a very strategic technology, and each country wants to ensure its own technological sovereignty. So it's complicated. And that is why I think we need everyone from all walks of life to come and talk about this. I mean, I'm just an engineer. And when I talk about quantum with philosophers and with lawyers and even with artists, they have a very enriching view of how they see the technology. And as well as, I don't know, with physicists or chemists, I think the point is to bring as many people to the table and to ensure that everyone has a voice. And some people say to me, but Esperanza, that is going to be a very messy conversation. And I always answer, yeah, but sometimes the meaningful conversations and the really productive conversations are messy and are structured, because that is how we humans are, right? We are not linear creatures. We are complex.
You mentioned ethical considerations. Do you see them different than the ethical considerations that are in the forefront because of AI these days? Again, why would quantum be different than the ethical AI conversation?
Well, I think there are a lot of similarities between the two fields, and certainly we will benefit a lot from cross-pollination between the two fields and learn from what the people in the AI business are doing. And coming also to my previous point, we know we can find answers, or we can try to find answers to questions that we are able to ask ourselves now. But there are many, many other questions that we are not even able to ask ourselves now, because there are still applications of quantum, and those applications might be unique for quantum that we will be discovering along the way. But I also think that the key point is, once you start thinking about any technology in ethical terms, in ethical perspectives, well, even if you face new things or if you face the same things, it's going to be productive anyway.
You mentioned that your training was as an engineer. Would you mind sharing how you got into quantum and what lessons you could share to other people that want to get into quantum?
Yeah, sure. Well, actually, the story about how I got into quantum is very nonlinear. Yeah, it's true. I'm an industrial engineer by training. And I would say an atypical industrial engineer because I was very interested actually in economy and finance and strategy. So I decided to pursue a degree in what was called at that time organizational engineering and business management. So I see programs in other countries, and that kind of studies would be sort of an master's in engineering and an MBA, sort of a mixture of those two. And then I started working in consulting, in strategy consulting, and then moved to finance. Now, what does all of this? How does all of this relate to quantum? Well, in a very non-linear and non-trivial way. I have always been fascinated by quantum mechanics. So I was reading on my own, and that led to quantum computing, and it was basically me being curious. And in the summer of 2019, I went for a short summer course at Harvard, and that totally changed my mind. The summer course was actually on innovation, so not related to quantum. But when I came back, my mind was bustling with a lot of ideas, and I started reading more. And I remember talking about this with one of my friends in the bank where I was working there. And he said to me at a point, "Listen, Esperanza, everything that you tell me is fascinating, but I don't understand a word of it. But there is this group called Quantum Madrid. They do gatherings and talks in Madrid, so why don't you join them? You will surely meet people with your same interests." So I did, and that way I went to my first ever talk about quantum in November 2019. in the headquarters of IBM. And then I started studying online in different institutions, for example, QTech, and also MIT X-Pro. And of course, the Qiskit Global Summer School organized by IBM. And it got to my point in early 2022 when I knew that I could no longer stay in my previous job, and decided to change jobs and to change my career. So this is my story. And in summary, what I would say is life is nonlinear. I mean, I could have never imagined that I would end up here. But my only piece of advice to those who want to enter the field is do as much as you can and do things that you feel that are important, that are meaningful to you. And this way, you will definitely find your spot in the community. So that is my advice. Of course, there will be moments of uncertainty, even moments of fear, because there is a lot of uncertainty. But at the end, everything will turn out well.
So given that, I wanted to ask you a hypothetical. If you could have dinner with one of the quantum greats, dead or alive, who would that be?
That's a fantastic question. Well, from people who are still alive, I think I will choose Peter Shor. I have not met him in person. I have taken some of his lectures at MIT X-Pro, and I think it would be super funny to meet him. Now, dead, I think this is going to be pretty obvious, but I think I would love to have dinner with Richard Feynman. And I think Feynman, a dinner with Feynman would be about quantum, but also about many, many other things, because he was a fascinating individual.
Very good. Esperanza, thank you so much for joining me today.
Thank you for having me.